Let's look at limit of a function in this video. For limit of functions, we make use of this notation. For example, if you see something like this, you can read this as, if you see a notation like this, it means that we want to find the limit of a function, and that function is f of x. You see something like this, it means that what x approaches a or x tends to a, but x equal to a, it is a wrong interpretation. Take note of that. This arrow means what? X approaches a. That is, approaches is very, very small. For example, if I say x approaches 2, it means that I'm looking at a number that is very, very, very close to 2. It could be 1.999999 or 2.0000001. Because these numbers are not equal to 2, you can see. But they approach 2 and they tend close to 2. And that meaning of this what? This interpretation. So whenever you see limit, you read it as what? Limit of f of x as x approaches what? Approaches what? A. Good. Now, take note that this gives us, for example, an answer I will call L. And take note, this L is less than what? Is less than infinity. Okay, good. Now, let's see. What are the basic laws of limits we need to know? They are very, very important. Let's look at what the basic laws. The laws of limits for evaluating limits we need to know. Now, the first law of limits we need to know is the one of the addition and subtraction what? Subtraction property. For example, if I have something like this, if I have the limit, let me put another color, hold on. So the first law is this. If I have when you have something like this, take note, it is possible for this limit to penetrate this, just like if you have a bracket b plus c, ab plus ac. The way this a multiplies out is exactly the way you multiply this limit. Then you'll be having something like this. The limit as x tends to what? X tends to a of f of x plus or minus the limit as x tends to a of g of x. Yeah, that's it. Also, the second one is this. If I have limit as x tends to a, in this case now, it is not sum but multiplication. For example, like this, f of x multiplying g of x. What will you have? This will be equal to what? This limit can be separated for these two. That is, you have limit as x tends to a of f of x times the limit as x tends to what? A of g of x. As simple as that. Also, next one. If I have the limit as x tends to a, but what I'm not having here is not a function of a, it's just a constant k. Your answer is equal to k. Let me give you the visual example. For example, I say limit as x tends to 2, you now have something like 4. What will be your answer? Your answer is still equal to 4 because you don't have any x here at all. All right. The next law, if I have the limit as x tends to what? A, you are not having like a constant in the bracket with the function f of x like this. You see this? It's the same thing as me bringing out the constant out of the limit. So I'm saying limit as x tends to a, it will just attack this f of x. As simple as that. The fifth law, if you are having the limit as x tends to a, remember this side we have products, but here we are having what? We are having division. For example, if I have f of x divided by g of x, what will be this? You can separate this limit for both of them. So we're having limit x tends to a of f of x all over limit x tends to a of g of x. And lastly, I'll stop here because all this law I've explained the basic laws of limit you need to know. We still have other laws, but for a beginner, we need to start from this side. So you have limit as x tends to a of what? F of x, all this to the power of what? To the power of n. Look at this. This f of x is taking a power of n. What do we do in this case? You see, it is possible for this limit to penetrate this bracket without even being affected by this n. What am I saying? Look at it. You'll be having something like this. The limit will penetrate this bracket, x tends to a, then what? F of x. Then what happen? You'll be having a power of n. You can see this limit can penetrate the bracket, then you still have your what? You still have your power. Now, these are the basic laws of limits you need to know. All right. Pen this down and let's start applying these laws. All right. So the first one we are going to be looking at is we have different methods for solving limits. So the first method we are going to be using here is what we call the direct substitution. The direct what? The direct substitution. So we have the direct substitution. So let's see. Now observe. If you are having something like this, the limit as x tends to minus 2, you are now having 4x raised to the power 3 plus 3x squared. Okay. Plus 1 all over 5 minus 3x. This is what we have. We want to solve this by direct substitution. You see, direct substitution means that if you're asked to evaluate this limit, you are going to plug in any value you have here, you are going to substitute it for the values of what? Of x. And take note of something. You see, we have some values that are what? Undefined. If you solve a limit, you are not having a value like 0 over 0, like a number over 0, or infinity over infinity, or you are not having something like what? Infinity. All these are what? Undefined form, in which we have several methods we can use to solve this limit. But let's proceed with the easiest one we have here. If you have a limit, your first method should be direct substitution. And what's the direct substitution property? Look at the property here. The direct substitution, the property of this is that if I have the limit as x tends to a of f of x, our answer is what? F of a. You see the property? Good. Now, let's go. It means that you are going to substitute the value of x inside this what? Inside this limit. And remember, let me just show you this step by step. This limit, we go for this, we go for this, we go for this, we go for this, and this. You will see it will be the same thing as me having limit as x tends to what? Minus 2 for the whole of the numerator all over the limit as x tends to what? Minus 2 for the whole of the denominator. You can see the property. Now, remember that for division, what happens? This limit can go for each of them. So I have limit as x tends to what? Minus 2 of 4s cubed plus limit as x tends to what? Minus 2 of 3x squared plus limit as x tends to minus 2 of 1. Then all over the limit as x tends to what? Minus 2 of 5 minus the limit as x tends to what? Minus 2 of 3x. Then you cannot apply this limit to all of them. And remember, if you're having a constant, it doesn't affect. It can just come out of the limit. So here I'll now be having 4, then negative 2 raised to power 3, then plus 3, negative 2 raised to power 2. And remember this property, that if I have limit as x tends to a of k, my answer is still equal to k. This one is a constant. You will still have this one back. Then all over, this will give me, this is also a constant. You have 5 minus, this will give me 3, then minus 2. This will give me 3, that's 2 to the power. This one will give me 8. 4 times 8 is 32. Then this will give me 4. Oh, sorry. This will give me minus 32. This will give me 4, then plus 12, plus 1, all over 5. Then negative times negative give me positive, and 6. So this will give me minus 32 plus 12. This will give me negative 20. Negative 20 plus 1, you have negative 19. Then all over, this will give me 11. So this is the answer to this limit. All right. So my next problem, I'll just keep substituting like that. Okay. So another problem by direct substitution is this. If I have the limit as x tends to, let me see, as x tends to 5 of x squared, let me see, 2x squared minus 3x plus 4. Look at this. What you're just going to do is just to substitute. So we're having 2, 5 squared minus 3, 5 plus 4. Then this will give me 5 squared is 25 times 5 times 2 will give me what? 50 minus 15, then plus 4. This minus this will give me, that's 35 plus this, that will give me what? 39. As simple as that. So let's take one more problem. What of if we have, if you have question like this? If you have the limit as x tends to 1, 1 plus 3x all over 1 plus 4x squared plus 3x to the power of 4, then everything all raised to power 3. Now remember, this is very, very easy. Remember that our limits can also penetrate this bracket. Do you still remember this law that if I have the limit as x tends to a of f of x to the power of n, it is possible for me to have this limit to penetrate this bracket like this. Then you still have your power n. So when this enters, what happens? You just apply the limit to all of them. Then what happens? Remember that if I have limits as x tends to 1 of 1, it will still give me this constant. Remember the limit, if s approach a of k is a constant, you still have k. Good. So this will give me 1. You still have your power. This will give me 1. This will give me 3 times 1. All over, I still have 1. 4 times 1 square, then 3, 1 to the power of 4. Then you have raised to power 3. So you give me what? This will give me 4 at the numerator. All over, this will give me 1. I'll have, this will give me 1 plus, this will give me 4, this will give me 3. And that will give me what? 8. So I have all over 8, then to the power of 3. So what will I have here? I will have 4 here, 4 here, 2. So 1 over 2, then all raised to power 3, and that will give me what? 1 over 8. And that's the answer to the limit. The next one is limit by factorization. So we have limit by factorization. So this is what we have. Limit by factorization. Good. Now, remember I told us that whenever we have some expression like 0 over 0, infinity over infinity, a number over 0, that will give us what? An expression that is not defined. So when we encounter such expression, what do? Part of the techniques that work is the one by factorization. Let's take for instance that I have, let me first give us a very simple question. If I have something like this, limit as x approaches 1, x squared minus 1 all over x minus 1. We all know that our first attempt should always be direct substitution. Then if I try that, what will I have? 1 squared minus 1 1 minus 1. And this will give me 1 minus 1 over 1 minus 1, which is 0 over 0. This is undefined. We can't present this as our answer. If you punch your calculator, you have math error. So let's see. Part of the technique that can work is technique by factorization. Please take note of this identity called difference of two squares. If I have x squared minus a squared, it is the same thing as x minus a, x plus a, or you say x plus a, x minus a. Anyone can come first. All right. So remember that this one is also the same thing as 1 square. So let me try to apply this difference of two squares here. Then I'll be having the limit as x tends to 1. Apply it, you have x minus 1, x plus 1, then you have over x minus 1. Observe what you have here. X squared minus 1 square is what? Just like you have x squared minus 1 square, a square. So your a is 1, and you have what? X minus 1, x plus 1. That's just the identity. So what happens? This one will also take care of this. Then you have the limit as x tends to 1 of x plus 1. Then you cannot apply your direct substitution. So what we have here, this will give me 1 plus 1, and my answer equals to what? 2. If I substitute x equals to 1, you have 2. That is the easiest of all questions by factorization. Okay, let's go a little bit further. If I have question like this, limit as x tends to minus 2 of x squared plus 5x plus 6 all over x plus 2. Now, observe. Let's try direct substitution. This will give me minus 2 all square, and that will give me 4. 5 times minus 2 will give me what? Minus 10, then plus 6 all over minus 2 plus 2. This will give me 0 over 0. And that's what undefined exponent. So I can't present this as my answer. So after that, part of what you should reason, we have other method to apply this and to evaluate this question. We have several methods, but one of them is factorization. So let's perfect this. So one thing again that was, since I'm dealing with factorization, let's factorize this. Can we factorize it? Let's go. Limit x tends to what? Minus 2. Remember, if I factorize this quadratically, I have x squared plus 5x plus 6. Just think of two numbers multiplied together to give me 6. And when you add them together, you are going to get 5. They are what? 2 and 3. So 2 times 3 is 6, 2 plus 3 is 5. So when you get these two values, you factorize them as x plus 2, then x plus 3. So I'll have it here. So x plus 2, x plus 3, then all over x plus 2. So looking at this will take care of this. So you'll be having that will be equal to the limit as x tends to 1 minus 2 of x plus 3, and that will give me what? Minus 2 plus 3, and that will be equal to what? Plus 1. And that's the answer to that question. Let's go a little bit further. Also by factorization. What of if you have the limit as x tends to 0 of 4x cubed plus 3x squared plus 5x all over x squared plus 7x. It is obvious that by the time I put 0 here, everything here will be 0, everything here will be 0. So what do? We factorize by doing this. Limit as x tends to 0. You observe that x is common to all of them at the numerator. So you bring out the x that is common to them. So you'll be having 4x squared plus 3x plus 5. Then all over x is also common at the denominator. You bring it out. So you'll be left with x plus 7. So take note that this one will take care of this. So you'll be having the limit as x tends to 0, 4x squared plus 3x plus 5 all over x plus 7. So if I substitute x to be 0, so you have 4 0 square plus 3 0 plus 5 all over 0 plus 7. So this will give me 5 over 7 as the answer to this limit. It's cool, right? Good. Let's also take steps further. Let's take some steps further. Let's take some steps further. What of if I have a question like this? Limit as x tends to 2 of s to the power of 4 minus 16 all over x minus 2. Okay, how do we evaluate this question? I'll put down some identities for us. Remember, I've given us difference of two squares, but what of if we have identities like this? S cube plus a cube. This will give me x plus a, x square minus ax plus a square. This is it. What if you have s cube minus a cube? That will give me x minus a, s square plus ax plus a square. You can see the pattern. Once it is plus, what you have here will be plus, minus, what you have here will be minus. Then for minus, you have plus all through, but for plus, it will fluctuate from minus to plus. That's for the first one. Secondly, what if you have s to the power of 4 plus a to the power of 4? So I also have x plus a, then x cube, then minus x square a plus xa square minus a cube, just like this. What of if I'm having negative? So you have x to the power of 4 minus a to the power of 4. That will give me x minus a, x cube plus x square a plus xa square plus a cube. That is it. So the pattern continues that way. And that is it. And remember that what I'm having here, I can rewrite it as the limit as x tends to 2, x raised to the power of 4 minus 16 is the same thing as 2 to the power of 4. Then all over x minus 2. So all over x minus 2. So what will I do from here? Pretty simple. Observe. I'll just follow this identity. Which one will I follow? I'll just follow this identity here like this. To get my answer, I'll just follow this one down here. So let's follow that. So I'll be having the limit as x tends to 2. So what will I have here? This will give me what? X minus 2. Then what will I have? X square. See, follow the identity. You see, follow this one. Anywhere you see a, put 2. That does it. So x minus 2. Then what will I have? S cube plus, 2x square plus a here now is 2. 2 square, then 4x plus a cube will give me what? 8. Then all over, what will I have here? X minus 2. Observe. This could take care of this. So I'll be having the limit as x approaches 2 of x cube plus 2x square plus 4x plus 8. Then you substitute 2 cube plus 2 square plus 4 times 2 plus 8. This will give me 8 plus 8 plus, this will give me 6 plus 8. 3 8 is 24. 24 plus 6 will give me 13. So this is very, very easy and simple. Let's take some other steps further. Okay. Okay. Let's see. What of if you have the limit as x tends to minus 3 cube root of x plus cube root of 3 all over x plus 3. Now, I want to do something. You can pause the video to attempt this question. Then, when you are done, you can play to see the correction. So, what will I do here? How many of us still remember this identity that, for example, if I have square root of x square, remember this takes care of this, then this gives me x. Similarly, if I'm having cube root of s cube, this same thing as well. This take care of this, and I'll still have x. Now, The thing is that you observe that in this numerator, I'm having cube roots. I'm having cube roots, but here there's no cube root. So how can I make this one have cube roots without changing the nature of the question? I'll just use that previous identity, which is the limit as x tends to minus 3. Then this is what? Cube root of x plus cube root of 3 over, I will write this as cube root of x cube, then cube root of 3 cube. If you observe this, sure. If you observe this, you see that if this takes care of this, I'll still have my x back. So I've not changed anything. Good. Now, after this, what's the next step? Observe that I gave us an identity. I'll still write it here. S cube plus a cube, which is what? X plus a, s square plus ax plus, this is s square minus ax plus a square. You have to be careful. So this is it. So that is it. So from here, I'll apply the identity. And what will I have here? Limit at s tends to 1 minus 3. So I'll still leave my numerator the way it is. All over. Now observe, here, take note that my x is cube root of x, and here my a is cube root of 3. So for you not to make mistake, anywhere you see x, put cube root of x. Anywhere you see a, because they are the one who want to apply the identity for. So this is my like x, this is like what? A. So let's go. So what will I have here? I'll be having, okay, I have x plus a, and my s is cube root of x plus a. Oh, my a is what? My a is cube root of 3. Then plus from this side, x square. You see, I'm having x square, so just square this, you'll be having cube root of x, then square. It's legit that way. Minus ax, that is minus ax means that you want to multiply, that's cube root of this times cube root of this, and that's even having cube root of 3x. Okay. All right, then plus a square. That will give me what? Cube root of a, then square. Good. If you observe what I'm having here, this and this must cancel each other. Yeah, they will cancel each other. Then if I now substitute my limits where x tends to what? Minus 3, what will I have? I'll just have this, you have 1 over. If I substitute minus 3, you have cube root of minus 3 all square, that will give me 9. Minus, this one will give me cube root of, this will give me minus 3 times minus 3, and that will give me what? Minus 9. Good. Then this one will give me plus cube root of minus 3 all squared, that will give me what? 9. So observe that this will give me cube root of 9. The minus can come out here for cube roots. You have plus cube root of 9. Also, this one will give me a plus cube root of 9. And my final answer to this question is 1 over 3 cube root of 9. Because I have cube root of 9 3 times. So that's it. Limit by rationalization. So I want to look at limit by rationalization. Okay. So how do you rationalize it? Observe that there are some questions that will be given where we won't be able to factorize. In such question, it's possible for us to know how to what? Rationalize it. Let me give us examples. See, if I have limits as x tends to 1, square root of x minus 1 all over x minus 1. Observe, there's no miracle I can use to factorize this. It's not possible. So what will I do here? Observe. Let me give you a trick. Whenever you are having square roots, make sure that what you want to rationalize. Yeah. So I'm having, and take notes. Where will you rationalize? Is it the numerator or denominator? You rationalize that part of the fraction that have square roots. And here is the one that has square root numerator. So I'll rationalize the word numerator. So what will I now do here? I will do what? I will rationalize the what? The numerator, which means that I will multiply both fractions by the conjugate of the denominator. That is, look at what I'm having here. Hold on. Look at what I'm having here. I'm having limits as x tends to 1, then square root of x minus 1 over x minus 1. Then I'll now multiply up and down by the conjugate of this denominator. So since I have square root of x minus 1, the conjugate is what? Square root of x plus 1 over square root of x plus 1. Now, this is what I have. Then what happens? If I multiply out, I'm having this and this will give me, remember, it will give me something like this. Square root of x square minus 1 square. Because if you multiply out, this is what you will get. All over, this will just give you x minus 1, then square root of x plus 1. Now, please take note of something. Don't touch the denominator. Don't expand the denominator. Leave it the way it is. Where you are going to multiply out is that point where you are rationalizing. Remember, I'm rationalizing the numerator. I'll multiply out the numerator and just leave the denominator the way it is. Yeah, just follow the instruction. So you'll be having, this will give me what? X minus 1 all over x minus 1, then square root of x plus 1. If you have expanded, you will not see that. You will not see that this, we cancel this. You might not see that. So from here, I'll be having the limits as x tends to 1 of what? 1 all over square root of 1 all over square root of x plus 1. And that will give me what? 1 over 1 plus 1, and that's 1 over 2. That's by rationalization, and that's the rudiments. Okay, let's see. Okay, let's see. What of if you have like something like a root at the denominator, x tends to 2 of x minus 2 over square root of x minus square root of 2. You see, before I solve this question, you will have seen that if you do direct substitution, you'll be wrong. So therefore, because if you do direct substitution, you have it 0 over 0. So remember, how do we know where to rationalize? Where to rationalize is actually that point where you have your roots, and that is the denominator. So you have the limit as x tends to 2, x minus 2 over square root of x minus square root of 2. So let us rationalize this part. So we have multiplied by square root of x plus square root of 2. This is what you have. So this part where you are rationalizing is actually where you should expand and leave these other points alone. Just like I've said earlier. So this one, if you multiply it, you have something like square root of x square minus square root of 2 all square. So this and this will take care, this and this will take care. So you have x minus 2. So you have x minus 2. So don't expand the numerator, so you will know that this and this will cancel out. So if I substitute the limits immediately, I'll be having square root of 2 plus square root of 2, and that will bring me 2 root 2. That's the answer to this limit. Let's proceed to some tough questions. Let me say I'm having, if you have something like a bigger square root like this, let me say you have a bigger square root like, okay, let me say you have the limit as x tends to minus 3 of x plus square root of 6 minus x all over x square plus 2x minus 3. If you observe that, let's see what happens if I put direct substitution. Let's see. If check out the denominator. 3, this one will give me 9 minus 6 minus 3, and your denominator is 0. Once your denominator is 0, the fraction is undefined. So it means that you must do limit by rationalization. And how do we use rationalization? There's a square root there. There's actually a square root there. There's a square root there. So what will you do? Let's move. Okay, we rationalize the numerator, which means that you multiply by the conjugate. Remember, what will be the conjugate? See error by students. They'll say the conjugate is this, 6 plus x. Why? It shouldn't be like that. it should be the sign between these two terms that you are going to change. That is, plus is between them. You are going to change it to what? To minus. Not what's inside this. Because here we are having two terms entirely. So you have x minus square root of 6 minus x all over x minus square root of 6 minus x. All right. And to give me the limit as x tends to minus 3 of what? This and this. Remember, this and this, difference of 2 squared. So we'll be ending up with x squared minus 6 minus x all square. And that will be giving you x squared minus 6. That's minus 6 minus x like this. So that will give me x squared plus x minus 6. X squared please hold on. Okay, yeah. X squared. This will give me x squared plus x minus 6 all over. The denominator I have x squared plus 2x minus 3. Then you have x minus square root of 6 minus x. Now, let's look at this. Do you have anything that can cancel out? Of course, it might not be obvious that something can cancel out now. You'll be like, wow, something is not canceling out. What should we do? There's still more to do. So, factorize this. If I factorize this, I'll be having x plus 3, x minus 2, all over. If I factorize this, I'll be having x plus 3, then x minus 1. Then I have x minus square root of 6 minus x. Good. Do you see that? So surely this and this will take care of each other. So I'm having the limit as x tends to minus 3 of x minus 2 over x minus 1, x minus square root of 6 minus x. Now, limit as x tends to minus 3. So let us just substitute. So what do we have there? From this side, we have minus 3 minus 2 minus 3 minus 1. And this will give me minus 3 minus square root of 6 minus minus 3. So yeah, this one will give me minus 5 over. This will give me minus 4. And this will give me minus 3 minus square root of 9. So because minus times minus will give me plus, 6 plus 3 will give me 9. So minus 5 all over minus 4 multiplied by, you see, this part I have minus 3 minus 3. And that will give me what? Minus 6. And that will give me, one of these, minus times minus will give me plus. I have minus 5 over 24. Minus 5 over 24. So 4 times 6 is 24. All right. That's it. Okay. Let's see one more problem on limit by factor and rationalization. And I'm giving us another problem that is entirely different. It's entirely different just because when you have roots at the numerator, you rationalize the numerator. And when you have roots at the denominator, you rationalize the denominator. Now, you'll be having roots on both of them, which is this, all over. All right. So what do we do from here? Let's see. If you do the substitution, it won't work. You can try that out yourself. So since it won't work, I will rationalize both numerator and denominator. So observe my working step. This will give me, I have square root of 6 minus x minus 2 over square root of 3 minus x -1. Then this I'll multiply by both up and down. So this one I'll rationalize the denominator. I'll also rationalize the numerator. So I can do any one first. So I have 3 minus x plus 1 over 3 minus x plus 1. Then I'll also multiply by the conjugate of this, which is 6 minus x plus 2. 6 minus x plus 2. So this is what I have. All right. This is what I have. Okay. So did you see? Now, let us now multiply out. This is how you should multiply this. You see, multiply this part and this one. So when you multiply that out, this is what you will get. 6 minus x, then minus 4. Please let me write that neatly. You have 6 minus x minus 4. Then that will give me. Okay, then all over. For this part, multiply this and this, that they are identical. So you'll be having 3 minus x minus 1. Then you have square root of 6 minus x plus 2. This is what you have. So what do we do from here? Let's substitute directly. Let's just substitute from here directly. So I'll be having, I'll have, for this part, I'll be having 6 minus 2 minus 4. This part I'll be having square root of 3 minus 2 plus 1. Then all over here I'll be having 3 minus 2 minus 1. Let me see. Observe that. Okay, please pardon me for this. Let's do something first. Let us simplify before we evaluate the limit. So let's simplify, like limit x tends to what? 2. This will give me 6 minus 2. 6 minus 4 will give me what? 2 minus x. Then this will give me square root of 3 minus x plus 1. All over. This will also give me 2 minus x. Then this will give me square root of 6 minus x plus 2. So if you refuse to simplify first before you substitute limits, you enter that trap I entered. And what you're going to do here is just cancel them out. Then you can now substitute your limits. So you have to cancel what is common out before you substitute your limits. If not, you run into an error. So you have square root of 3 minus 2 plus 1 over square root of 6 minus 2 plus 1. And that will give me what? 1 plus 1, that will give me 2. Let me show you. 3 minus 2 is 1. Square root of 1 is 1. 6 minus 2 is 4. Square root of 4 is 2. 2 plus 1. That will give me 2 over 3. That's just the answer to this limit. That's 2 over 3. So that is it. So if you are watching this video, let me give you a task and comment your answer. Put your answer in the comment section. So let's engage in this together for me to know we are on the right track. So if you truly understand this, then evaluate this limit and comment your answer. Evaluate this limit. The limit as x tends to minus 4 of square root of x squared plus 9 minus 5 all over x plus 4. So evaluate the limit. What is the answer to this limit? So evaluate it. Let's proceed to limit to infinity. Now, remember that this is what we call infinity. So when we have limits involving this, what should we do? All right, under this aspect, we are going to learn something. Observe that if I have the limit as x approaches infinity of something like this, let me say n over x. Observe, you see, this infinity represents a number that increases out of bound. We don't know. The fact is that if we count the numbers of grains of sand that we have on the universe, they are not up to infinity, they are less than infinity. So that's just it. So it increases out of bound. If you observe that if I have a fixed value like 5, I'm now having 5 over 10. This will give me 0.5. If I have 5 over 1,000, this will give me 0.005. If I have 5 over 10,000, you have 0.000. You see, this value will be what? It should be tending to something. And what is that in 0? It means that what? As this denominator approaches what? Infinity, your answer here will be equal to what? 0. That's just the fact. Because if you keep increasing the denominator of a fraction and you have your numerator to be fixed, what happens? The value will be tending closer to or closer to 0. So this is the first thing you will learn. Secondly, what of if you have something like a to the power of what? Infinity. This can have two values. It can have 0 and it can have infinity. It can have 0 if a is between 0 and 1. If a is between 0 and 1. And it will be infinity if a is greater than 1. So take note of it. So if I have 2 over 3, if I have 2 over 3 up to the power of infinity, whenever I'm solving, I come across this. What happens? This value will tend to 0 because 2 over 3 is between the 0 point something. So it is in between this. So it satisfies this. So you have what? 0 as required. All right. So from here, let's take some value. Let's take some problem. How do we evaluate question under limit to infinity? The simplest of all the problem is this. To evaluate limit at infinity, if you see something like this, divide by x of the highest power. Observe that the highest power of x I have here is just x to the power of 1. It means that to evaluate this limit, you are going to divide each of the term by x raised to power 1. Assuming you have s squared as the what? As the highest power of x that you have, you divide each of the term by what? X squared. So I have 2x here all over what? All over x plus 1 all over x. Here I have 3x all over x minus 1 all over x. Now observe something. This will take care of this and this will take care of this. So I'll be having the limit as s tends to what? Infinity of this will give me 2 plus 1 over x, then 3 minus 1 over x. Observe, see this identity here. I'm having 1. This one represents this end you have at the top. And x that is here is approaching infinity. So it means that my answer here, this will approach 0, this will approach 0, and my answer is 2 over 3. I believe you are getting the concept. That's just it. So that's how we evaluate limit to infinity. Let me solve one more simple problem. Assuming you have something like this. Limit as s tends to infinity of 2x squared minus 3x plus 5 all over 8x squared plus 7x plus minus 9. Before you go to advanced ways of solving limits, before you learn how to solve limits of the advanced problem, you need to be firm in all these aspects. Then from here to solve advanced problem will be really easy. All right, from here, if you observe, the highest power of x I have is what? X squared. So you divide each of these terms by x squared. So if I divide this one by x squared, I'll be having 2. If I divide this one by x squared, I'll be having 3 over x. If I divide this one by x squared, 5 over x squared. If I divide this one by x squared, I'll have 8. Plus this one give me 7 over x minus 9 over x squared. So observe, all this will approach 0. So you're having, your answer will now be what? 2 over 8. It means that the shortcut of solving this limit is that whenever they give you limit like this, just pick the coefficient of the highest power of x to be your final answer. Remember, the highest power of x is x squared. So just pick this 2, just pick this 8. You will have the answer here. That's 1 over 4. Also here, pick the highest power of x that I am, the coefficient of the highest power of x that I have here, that's 2. Also, this 3. Simple. Oh, the last question we're going to be looking at under limit to infinity is a question that will actually combine the concept of rationalization and also limit to infinity. Observe this question. If you have the limit as n approaches infinity of square root of n plus 1 minus square root of n. You can pause this video to give this problem a trial. So let us see. What do we do from here? Firstly, we rationalize. Before you even apply infinity, we rationalize. That is, let us rationalize what we have here. This will give me what? I have square root of n plus 1 minus square root of n. So you can just multiply this by the conjugate. And what's the conjugate of this? That will give me square root of n plus 1 plus square root of n all over square root of n plus 1 plus square root of n. Okay? From here, we have limit as n tends to infinity. This and this will multiply out. You'll be having n plus 1 n plus 1 minus n. Then all over, this will give me square root of n plus 1 plus square root of n. So this will give me the limit as n tends to infinity of 1 all over square root of n plus 1, then plus square root of n. Good. Now, what do you think we can do from here? Of course, from here, if I rationalize again, it will shock you that we'll come back to what we have been solving before. So you rationalized already, you can still proceed to rationalize again. So this is what we have. So since we have this, what can we do? Observe, the highest power of n I just have is square root of n. Yeah. So let me divide each of the term by square root of n. So observe, I'll be having limits as n tends towards infinity of what? 1 over square root of n. Then I have square root of n plus 1 all over square root of n plus square root of n all over square root of n. So this will give me the limit as n tends towards infinity of 1 all over what? Square root of n, to give me 1 over square root of n all over. This can be written as square root of n plus 1 all over n. They both have square root, so I'll just give them one square root, then plus this will cancel out to give me 1. So this will give me the limit as n tends towards infinity of 1 over square root of n all over. This can be separated. Remember that if I have a fraction like 2 plus 3 over 5, I can say 2 over 5 plus 3 over 5. If that is the case, I'll also do the same thing here. So if I say n over n, that will give me 1, then plus 1 over n, then plus 1. So do you remember? Do you remember what we've learned before? That I said if you have the limit where what? Where x tends to infinity of, let me say I have a over x, my answer will be equal to 0. This tends to infinity. Observe, see, this, what you have here have tend to what? Tending to infinity. What you have here is what? Is tending to infinity. What you have here is tending to what? Infinity. So it will just be equal to what? 0. So you have 1, everything here will be equal to what? 0. So you'll be having what? 0 all over. This will give us square root of 1 plus 0 plus 1. And that will give us square root of 1 plus 1, and that's 2, and my answer is equal to what? 0. So the final answer to this question is 0. You can see. So that's how we work our problem. So thanks for watching. Try to subscribe, like, and share to your friends that probably need this video. So bye.